Hello everyone, and welcome to the final tutorial video here involving exponents, rational exponents that is, and radicals. Here we are doing simplifying expressions involving rational exponents 2, basically a continuation of the previous video, but taking it, to the ultimate step, getting a little bit tougher. So, in this example, we have v to the 4/3, oh, hello Bill, over v to the 2/3 times v to the 4/3. Now there are a few ways that I can look at this problem. For one thing, a really quick thing I can notice is that those v to the 4/3, since it's all being multiplied and divided, I could just cancel that because v to the 4/3 divided by v to the 4/3 will cancel. However, let's say that I didn't notice that, or let's say that, it wasn't exactly the same. Well, let's just go ahead and work it out step by step. But that would be a quick way that you could tackle this problem. So, essentially, since I'm multiplying, let's take care of this first. So since I'm multiplying, I'm going to add my exponents. So, man, I have to tap things multiple times for it to respond. So on the top, I still have v to the 4/3. Oh my. This is really acting up. So v to the 4/3 is still on top. That is not any better. Okay, and on the bottom, I'm going to go ahead and skip this step. 2/3 plus 4/3 is 6/3. So v to the 6/3. Okay, so next, well, I'm dividing, so I'm going to have to subtract the exponents. So my biggest one, I'm going to highlight my biggest one. My heavens, what is up with this? So my biggest one is on the bottom. So that is where my v's are going to stay. So we're going to have 1 on the top. And then it's going to be v, 6/3 minus 4/3 is 2/3. And if you needed to see more with dividing rational expressions, please see the prior video when we did that in 3. But yeah, that's really all we do there. So 1 over v to the 2/3. So let's move on to the next one, if possible. So let's say that I have a stylus that doesn't work. That's what we have. Alright, so x to the negative 5/7, and we're multiplying that by x to the negative 3/7, and all of that is over x to the negative 9/7. So here we have a bunch of negative exponents. So kind of going to move a little faster in this because this really, regarding part by part. But I'm multiplying on the top, so we're going to add our exponents here. So negative 5/7 minus, or negative 5/7 plus negative 3/7. So when I do add those, it's going to be x to the negative 8/7 on the top. And that's going to be over x to the negative 9/7. Alright, so last thing, I'm dividing. So if I'm dividing and I have the same base, going back to M3, I'm going to subtract the exponents. So which one is the biggest? Well, I have to consider negative 8 or negative 9, which is greater. Well, actually negative 8 is greater because it's not as far from 0, where it's actually, if well, hold on. Let me rephrase that. It's actually not as far down as -9 is. -9 is further below. It's like -9 would be a colder temperature than -8 would be. So that means our x's are going to end up being on the top. So we're going to end up having x to the -8/7, and I'm subtracting, so -8/7 minus -9/7, and that's going to be over 1. So I really don't need to put it, but that's going to be x to the -8/7 plus 9/7 is x to the 1/7. And that's really all I can do there. Yeah. All right, so let's do one more, or two more, I guess. Might as well. So here we have 16f over f, and all of this is to the 3/4 power. Well, on this one, you can make your life much easier by go ahead and dealing with the f's first. Well, f to the first divided by f to the first, well, subtract 1 minus 1 is 0. So the f's essentially cancel. So we're going to cancel those out. And I could have done that on the first example in this video, but just kind of show you how this works. There are multiple ways you could do this. So that's going to leave me with just 16 over 1 to the 3/4, which is basically just 16 to the 3/4. Well, 16 to the 1/4, because 16 is a perfect fourth, would be 2. 2 to the third would be 8. So that's kind of how that would work. But you can always type it in the calculator. To verify, just be sure you put the fraction in parentheses. And so I get 8. Okay, one more example. All right, so let's make this one a tough one. Let's do 81 r to the 2nd over 16 r to the 5th. And let's do this whole thing here to the 3/4 power. All right, so first, before I deal with that exponent outside, let's take care of the stuff inside first. Okay, so 81 and 16, they don't have any common factors, so I can't really, besides 1 won't do anything though. So I can't really do much there. But I can deal with those r's. I'm dividing, so r to the 5th is greater. So that's my highest one. So my r's are going to be on the bottom, on the denominator. So we're going to have 81, and I don't have any r's on the top anymore. And I'm going to have 16. Okay, and then 5 minus 2 is r to the 3rd. So I have 16 r to the 3rd on the denominator. And then this whole thing is to the 3/4 power. Okay, so rule. Whenever I have an exponent outside the parenthesis, everything must go to that exponent. And if I have other exponents, those exponents are going to multiply. So this is going to be 81 to the 3/4 power over 16 to the 3/4 power, and then r to the 3rd times 3/4. We're going to multiply that exponent. Okay, so let's see what those are. So 81 to the 3/4, I know that's going to come out to be a whole number because I know 81 is a perfect fourth. It would be 3. So basically 3 to the third is 27. So I should get 27. So indeed I do. So on the top we're going to have 27. And on the bottom we're going to have, well, same thing with 16. It's a perfect fourth. So 16 to the 3/4. 8. I think we did that in the last example, didn't we? Okay, and then that's going to be R. Okay, multiply my exponents. 3 times 3/4 gives me 9/4. So I have 27 over 8R to the 9/4. And I believe that is really all we can do there. So I hope that you found this helpful. And, of course, if you have any questions, feel free to message me. And, well, that's really all I got, y'all. So good luck with it, and I hope you all have a wonderful day.